Hi, Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Muhammad Shakib bin Umar Basri. Okay, today I would like to present about my project. It's called Autonomous Cleaning Robot Vacuum for Indoor Space. And my supervisor name is Puan Rojilawati binti Muhammad Noor. Okay, this is an introduction of my autonomous cleaning robot vacuum for indoor space. Okay, this is an introduction. In present day, robotic cleaner have taken major attention in robot research due to their effectiveness assisting human in floor cleaning application at home, hotel, restaurant, office, hospital, workshop, warehouse, and university. Robot vacuum cleaner are well-known product in the market. The rapid development of robotics has been growing year after year as science and technology has progressed. It is a part of life to use robots to fulfill human needs. As people demand grow, robots have recently been established as a home appliance exploration of home mechanical machine technology. It's becoming more complex than it has been. Large robot vacuum currently available for both domestic and industrial use. However, the activity are not self-contained and they can only perform a limited number of tasks. Okay, robot vacuum is also known as a robovac, where it's a vacuum cleaner that has a certain degree of autonomy from the user and is programmed for cleaning activity. Vacuum robots have reduced the use of manpower to clean the house or office. Vacuum robots are designed to help people complete their tasks. The project aims to create a semi-controller robotic vacuum using Arduino and application to control on, off, and control movement manually on phone over a specification called as IoT, Internet of Things. Existing robotic vacuum are more expensive and large scale. This robot simply the cleaning process for humans who want to clean automatically or manually on a smartphone. These robots are built to make interfere human effort, especially to clean the house. This project is perfect for someone who has little time at home and to clean the floor. Okay, next is a problem statement. Technology become an important part of human life, helping people in complete their tasks. People who sweep the floor and most people who work have to concentrate on their job and don't have enough time to clean. Using a regular vacuum cleaner require a lot of work and supervision from the user, so they need a robotic vacuum cleaner to do their job for them. A large number of conventional robotic vacuum cleaner on the market expensive and large in size, so it is difficult to clean anywhere. Feature users are busy observing their robot during the cleaner process and are able to waste energy. Therefore, this project is built to be one of advantage for human, that is to clean the floor in a small amount of time and less supervision. Apart from users who don't have time to clean the floor, this robot vacuum is also great for users who feel lazy to sweep the floor at home. Therefore, this robot vacuum is great to help users to clean the floor such as dust or dry and small garbage automatically or manually using the application on the smartphone to facilitate to clean the floor without user supervision or manpower in doing floor cleaning work at home. Due to the high cost, almost make it difficult for users to own a robot vacuum at home. Therefore, this robot vacuum is made to convenient and affordable for a user who have less time or are lazy to clean the floor manually. Okay, next is a project objective. Okay, this project objective is to develop an autonomous vacuum robot for indoor space using Arduino. Then to design a controller system for robot using IoT. Means we use a Blink for IoT to connect a Wi-Fi module ESP8266. And the third to analyze the performance of the proposed method for robot vacuum. For scope of project, the scope of this project is implementation of autonomous vacuum cleaning robot for interior space such as home and office. It uses a Arduino Uno as a microcontroller to run this automated system. It also uses several to detect obstacles and stairs so as not a fall from high place. The sensor that will be used are ultrasonic sensor and infrared sensor. In addition, this autonomous vacuum robot use a IoT using application method. So it require a Wi-Fi module of the ESP8266 model. Wi-Fi module to control device over the internet. It can work with a microcontroller like an Arduino or can be programmed to work on its own. In this project, the robot vacuum will move freely until the ultrasonic sensor detects an obstacle in front and will change direction to continue the movement. The project does not promise through clean input can provide convenience to users who want to use it for small areas as well as indoor areas. Okay, now we go to methodology for autonomous cleaning robot vacuum for indoor space. Okay, this is overall project methodology, flowchart for autonomous cleaning robot for indoor space. Okay, I refer to these two figures. The flowchart show the step of to complete this project from the title chosen until end of process that submit report and presentation. Firstly, after the get the title of project, do a research about the title, research also previous project that student final year has done, and do a development or think idea that can make for project. After that, I must know what want to use for project and what application must research. Okay, and then start implementation for project until submit final report. And that's end. Okay, this is project development based on the expansion of project. This project is an improvement project from other that is already commercialized in the industry. Major device parts such as Arduino Uno as a microcontroller and L298N motor driver, DC gear motor, ultrasonic sensor, infrared sensor, centrifugal fans, relay, 12-volt LiPo battery, and ESP 8266 Wi-Fi module as the Internet of Things IoT usage for controller. Okay, now we move for hardware development. This project system consists of several system components that can be used, namely obstacle avoidance system, ladder detection, as well as internet connector between the vacuum robot and the smartphone. This vacuum robot will move freely until it is object in front or ladder that will make the robot change direction. This robot will move to carry out the task of cleaning up dry and small debris. Okay, this is design robot vacuum. This is my design. Okay, front view robot vacuum. We can see transient sensor, DC motor, and vacuum fan at bottom. Okay, and this is a side view for robot vacuum. We can see the infrared at the bottom of robot. And this is a top view. We can see that Arduino Wi-Fi module ESP8266, and we have switch, and we have LiPo battery, we have motor driver L298N, and we can see a relay. Okay, next the mechanical design. Okay, based on my design, you can see. Okay, next vacuum process development. Okay, as you can see, there is a flowchart about my system autonomous cleaning robot for indoor space. Okay, based on this figure, first connect the Wi-Fi module with the Blink application. It will be accessed. If it fails, try to reconnect the hotspot. If successfully, the vacuum robot can be turned on. The on-off button and the vacuum robot can move automatically or control through the Blink application. Then the vacuum robot will move freely while the vacuum cleaner the floor as well as small dirt and dry dirt. When there is an object or wall in front of the vacuum robot will stop and change the direction of movement, and then no obstacle in front, then the vacuum robot will continue to walk forward and continue cleaning the process is complete. Okay, now we move to the hardware requirement. Okay. Hardware requirements, some of the components must be taken from this autonomous cleaning robot vacuum during its design or development. The Wi-Fi module ESP8266, HCSR04, authority sensor and infrared sensor, DC gear motor, wheel, L298 and motor driver, relay, 12-volt LiPo battery, Arduino Uno, such as microcontroller and such fans. This is where I use for my project for autonomous cleaning robot vacuum for indoor space. Okay, that's all component I use. Okay, this is our ultrasonic sensor. That's a sensor most widely used to detect the obstacle. Ultrasonic sensor is an instrument that uses a sound wave to determine the distance from the target or the barrier, and there has a different frequency per second. Okay, because it's cost effective, it's too easy to change. Ultrasonic sensing is one of the greatest way to detect proximity and very accurate speed. Each measuring precious is efficient and consistent in range. Second component, infrared sensor. Okay, infrared sensor also used in this project to detect the stair so that not to fall from the stair. Typically, infrared detection system consists of five fundamental components: it's infrared source, transmission channel, and optical component. Infrared detect or receive and signal processing. Next, I use L298 motor driver. Okay, the motor driver circuit is robotic or the application often work with a DC motor for forward or backward travel and can manage the speed of two DC motor, manage two polar motor simply. Okay, the L298N is a dual bridge motor driver that allow for a simulated speed and direction control of two DC motor. And then Arduino Uno, okay, thousands of projects ranging from everyday object to sophisticated scientific apparatus have been created with Arduino through the year. This open source network has drawn a global community to teachers, amateur, musicians, programmers, and practitioners who have contributed a wealth of useful knowledge that will help both beginner and expert. And then I use DC motor gear standard for wheel. And then I use relay. It's electrical which has moved from the off the position try electromagnet rather than by a person. Relay require only a modest amount of power to switch on, but it can control something that consumer much more. Relay a low one or higher current circuit to be controlled by a low current circuit. Relay are commonly used to manage the power as well as switch the smaller current value in a control circuit in a control panel, manufacturing, and loading automation. I also use ESP8266 Wi-Fi module to connect with a smartphone which called uh, Internet of Things, it's IoT. We can on off in smartphone or we can control manually in the smartphone. So okay, and then I choose a LiPo battery 12 volt because a space limit. This is fantastic choice for anything that demand a small or compact battery with a lot of punch. The voltage of 3 cell in series is low enough to avoid turning your voltage regulating circuit into a hot plate, and the discharge rate is higher enough to support a lot of electronic and a few large motor. Okay, lastly, centrifugal fan. This centrifugal fan will work when the robot is turned on and will start sucking dirt according to the direction movement of the robot. Next, software requirement. Okay, this software application play a significant role in achieving the intended outcome. Okay, this initiative compressed software for controlling, which may include Arduino IDE and Blink. Okay, to model and execute this project, a variety of technology were accessible this phase of software development for this project goes over the feature of the Arduino and Blink in greater detail. Arduino IDE is the software. Arduino is an open source framework for creating project electronic component that must be programmed and operate to be complete. Okay, this is Arduino for coding. This software Blink that I use to connect my robot vacuum and the smartphone. Okay, this Blink is the IoT used in this robot vacuum project. So this is one of the my objective. It also has a on-off button and manual control in this Blink software. This Blink will be connected via hotspot or call internet network to connect the robot vacuum with the smartphone, so that it can be used to connect a robot vacuum with a smartphone. This is initial result. Okay, this is a simulation that I have done for my PSM1 simulation motor movement coding, and this is example motor movement. Then it's a simulation ultrasonic sensor. Okay, simulation ultrasonic sensor LED on, and it's a simulation ultrasonic sensor LED off. Okay, this is coding for obstacle. Okay, we can see that the next for the video simulation. Okay, now we will go to the simulation test. Okey, ini adalah initial result yang dapat dibuat untuk PSM1. Okey, ini adalah simulation pergerakan motor untuk robot vacuum. Ada L298N motor driver, ada Arduino Uno dan ada motor. Okey, ini adalah coding Arduino di mana pergerakan motor akan mengikut arahan coding yang telah disetkan. Dapat dilihat di sini digital write. Ini adalah daripada connection Arduino dan motor driver. Okey, sekarang kita akan cuba run simulation ni. Okey, arahan yang pertama, motor akan bergerak forward. Okey, lepas itu dia akan delay selama 5 saat. Coding kedua akan dibaca yang membuatkan motor bergerak reverse. Okey, dan dia akan delay lagi selama 5 saat. Dan kemudian coding ketiga akan dibaca di mana motor akan membuatkan robot bergerak ke kanan dengan motor kiri bergerak forward dan motor kanan bergerak reverse. Dan akhir sekali, coding yang terakhir adalah untuk robot bergerak ke kiri dengan membuatkan motor kanan bergerak forward dan motor kiri bergerak reverse. Contoh pergerakan motor boleh dilihat di slide sebelum ini. Okey, ini pula initial result kedua iaitu simulation untuk ultrasonic sensor untuk detect obstacle yang berada di hadapan robot. Dan apabila ultrasonic sensor detect obstacle di hadapan, maka robot vacuum akan menukar arah pergerakan. Okey, ini adalah simulation procedure serta coding yang telah disetkan. Okey, sekarang kita akan cuba runkan. Okey, dalam coding ini saya setkan apabila jarak 10 cm dan ke bawah, maka LED akan bernyala. Bermaksud ultrasonic sensor ini dapat detect obstacle di depan. Sekarang saya cuba naikkan. Okey, dan apabila jarak lebih daripada 10 cm, okay, maka LED akan padam, bermakna tiada sebarang pengesanan oleh sensor ultrasonic. Okay, for the last is conclusion. Okay, this project named Autonomous Cleaning Robot Vacuum for Indoor Space. The goal of this project is to create and implement a low-cost and intelligent Internet of Things (IoT). This autonomous cleaning use sensors such as ultrasonic sensor and infrared sensor. The vacuum robot will move while cleaning the floor until there is a barrier in front and will change the direction of movement through a detecting sensor. That is an ultrasonic sensor. In addition, this project also use infrared sensor to detect stairs to prevent them from falling. This project robot cleaning does as well as more dry debris of unknown type, as this project has not been fully met. The project is still in process, will be known once fully complete. This robot is made to reduce manpower as well as for users who do not have time at home to clean the floor. So this robot is suitable for user, and this vacuum robot is also affordable because the cost of this robot is low. Finally, all development about this project will be known when project 2 has been successfully made fully, whether successful or not implementing the project autonomous cleaning robot vacuum for indoor space. Okay, this Gantt chart for my project I do from week 1 until I present to the panel. Okay, this is first briefing by JK PSM, propose making, submission of proposal, title register, and submission of project title. And then for the week 2 and week 3, background study of the title projects. And then I start chapter 1 introduction in the week 4 and week 5. Okay, and then chapter 2 lecture review, I start week 5 until week 10. I do a research for my project autonomous cleaning robot for Indospace. Okay, now and then the chapter 3 methodology I start in week 10 until week 11, and I continue. And then analysis component part of the project I start with week 11 and week 12, and the result rate analysis also I start for week 11 and week 12. Okay, for the conclusion I start with week 12, and week 13 I must edit my report because my supervisor told me to edit. And then for the last presentation phase 1 and week 14 I also done by this video. So enjoy for my video. That's all for my presentation about my project autonomous cleaning robot for Indospace. Okay, thank you.